I've been off and on involved with relational databases pretty much since I started working as a software engineer. I started at Sybase in 1989 and worked on the database engine there. And that was the database engine that was at some point forked to be the Microsoft SQL Server. And when Perl first made it easy to integrate C libraries, I did a proof of concept where I integrated the Sybase dblib into Perl so that you could write Perl clients that could access the database. And I didn't get a chance to present about this. Someone kind of beat me to it. And that DB, I think he called it DB Perl, ended up being kind of a foundational piece for a lot of web applications. I know that CNET was using it, for example, in the early days of the web world. Since I started primarily working in Erlang, I've been involved in a number of projects that have included, talking to a relational database. And what I observed is that everyone kind of was trying to solve the same problems, but doing it in different ways, and doing so in ways that were not necessarily the most efficient, or were actually pretty buggy. And then when I was at the Berlin conference this past October, I was at a number of presentations where the presenters would kind of say offhand things about why is it so hard to use relational databases or SQL from Erlang. So I thought that it'd be useful to start a conversation about what we can do as a community to try to make this a little bit better. So this presentation is some of my observations about where the problems might be. But I'm kind of limited by the sample size of the projects that I've worked on. So let's dive in. So at a very high level, what we're talking about are clients, what Sybase used to call client-server applications, where the server is a database, a separate process, and the clients communicate with it using some sort of network connectivity library. And so if we start thinking about this, this presentation is going to go sort of bottom up. So the first bit is, how do we do the plumbing? And most databases are commercial databases. They're closed source, right? So if you're going to use Microsoft or Oracle or any of these, the networking is not documented. The protocol is not documented. So you have to rely on the libraries that that vendor provides in order to make the connections to the database. So if we were to use an open source example, Postgres has a library called libpq. In some cases, there are native implementations of this in Erlang. There's EPG SQL. And you're able to do that because the Postgres is open source. The protocol is reasonably well documented, so it's possible to kind of write your own implementation of it. But outside of that, you really have to rely on these libraries. And these libraries are primarily intended for working with programs written in C, although there's also some Java equivalents and some C# equivalents. A first stab and the challenge there is that each of these libraries has its own API. Right, so if you were to, implement something to, say, Microsoft, the Microsoft libraries, you couldn't use that same code to use the Oracle connectivity libraries, right? You'd basically have to rewrite everything. So that's a hindrance to having good portability, and it's also something that makes this kind of hard. ODBC was an early attempt to try to provide a common API to talk to network databases. And as it happens, ODBC was being developed while I was at Sybase. Tom Hagen was one of the engineers that was working on this in collaboration with engineers from other companies. And the idea, and the initial cut of ODBC was essentially a dumbed down version of Sybase dblib. So there's a lot of, if you have complaints about ODBC, you can kind of blame Sybase for some of these decisions that were made early on. And the idea behind ODBC is that there's a common API that you can program to, And then the database vendors, it's like Oracle or Sybase or Microsoft, they provide a driver that is essentially the translator for the ODBC APIs to the network protocol specific to that database engine. And when we talk about this plumbing, there's a lot of other things that we could talk about, but this is a short presentation, so I'm not going to go into a lot of detail about these things. But there's questions about how do you handle the connection management or the pooling, right? Typically, these database applications in Erlang will create a worker pool of the connections, but there's a lot of considerations around that. There are certain sequences of operations that have to stay on the same connection. So for example, if you create a temporary table, only that session can see that table. It could also raise questions about privacy issues, right? If you don't clean up that temporary table and then reuse that same connection for something else, for another request, you could potentially leak information from one request to the other, and that could raise privacy questions about the privacy of the data. There's also, how do you model the database transactions in the Erlang code, right? There can be this bit of a mismatch between you started the transaction, you do a bunch of things, and you want to roll back, but or maybe the Erlang process crashes. How do you kind of manage that with the connection? How do you cancel the transaction and handle the rollbacks? And I think in speaking kind of a little bit more generally about this, is that the database sessions have a lot of statefulness to them. Transactions is one example, but there are others. You can have other properties that you associate with a session, things like what is the session's time zone, right? Does that information need to get reset when you use that connection for another request? Or even things like the isolation level or the compatibility level. These things are very important to how you interact with the database, but if you're recycling the connection, are you kind of resetting it the right way? And these are all things that would need to be managed when you use the connection pool. Again, making things a little bit harder, making things complicated. Stepping up, rising up a little bit, now that we can actually communicate with it, talked about how we communicate with the database, the question now is about how do you formulate the SQL? And so while there are standards around SQL coming from ANSI, ANSI is interesting. In order to see what the standard is, you have to buy it. And it's a couple $100s to buy the books that represent the standard. It's not a public standard. And in any event, the standard really defines kind of a minimum level of support. So a database engine can say, well, we support ANSI 89 or ANSI 2000 something. And that means that they have all that functionality, but typically they also have a lot of extensions. And these extensions can be features that make them unique, or they could even be features that are legacy. So when I was at Datometry, we were working a lot with Teradata, and Teradata had all these idiosyncrasies. Like for example, the clauses could be in any order, right? And you didn't have to have a from clause. Which is completely non-standard, but continues to be supported in that SQL. So there's these dialects that again, introduce some complexity, particularly if instead of being, there are kind of two categories of users, right? There are people that are going to be building applications as the end user of that application. They've probably made a decision about which database vendor they want to use, whether it's Postgres or Microsoft. In which case, the fact that the SQL dialects are there probably doesn't make too much difference. Alternatively, you could be trying to develop a library that you want to share with a lot of people, in which case you need to then think about what about the impact of these dialects and whether or not you want to stick to a standard SQL. So again, ODBC tries to provide a common API, and that extends to a common API around the data types and the syntax. So for example, with data types, ODBC has their definition of data types, which is that column, the ODBC column, which generally corresponds to what most databases use for their SQL types. But these types, there are some gaps. So for example, the timestamp with time zone SQL type, which shows up in a couple of databases now, has no equivalent in ODBC. So if the driver is conforms exactly to the ODBC spec, there's in fact no way of retrieving that data, right? You can't select that a column of that type and actually get that complete timestamp with time zone value out. And in Erlang, the representation in Erlang, there may or may not be one, right? There is no representation of a time interval, right? A standard representation in Erlang of a time interval. So you have to make something up. And maybe that's a string, maybe that's a tuple of some sort. And the one that kind of tripped us up a little bit was the numeric type, which is a fixed point value. And the precision of that value, that's the P, can be larger than the precision of a double, which means that you can't really represent these values as doubles. You'll lose some data. And they're also meant to be very, the math on them is supposed to be very precise, unlike doubles where there's this weird rounding that can happen on certain kinds of math, right? So how would you want to represent that, say, in Erlang? Maybe you could use a double, but maybe that's not the best thing. Maybe you want to represent that as a tuple, right? So again, add some complexity to how we interact with databases. And ODBC also tries its best to provide a common kind of SQL, right? Now keep in mind that ODBC was something that was created 30 years ago, before there were quite as many standards as there are now. So it has this additional syntax that you can add to your SQL code to try to normalize your SQL so it will run on multiple platforms, multiple database engines. So there are things like sort of a normalization of function names and how you represent dates and that sort of thing. But then, so again, this is an attempt to try to get rid of the problem of the dialects of SQL. But then are we just learning a different kind of SQL? Or are we now forced to think about only using the least common denominator of the SQL? And maybe we picked the particular vendor for our database because it has extensions that we want to use, that we want to take advantage of, right? So again, add some complexity to this whole process of trying to integrate Erlang with SQL. So, but how do we even generate the SQL, right? There are lots of libraries that some of them are kind of ORM-like, some of them are templating. A lot of times people just write code that mashes the strings together. Again, these are things that are kind of complicated. And these libraries will try to keep their life simpler. So they'll try to generate sort of a SQL that is agnostic to the dialect. But then they're forced to be using kind of the least common denominator of SQL. And when there's any kind of complexity to the queries, a lot of these libraries, and I'm thinking like something like Ecto, right? It's almost like a DSL, right? You're kind of describing what you want. And as the query gets more and more complicated, it's like, well, I already know how I want to express this in SQL. Why do I have to learn how I want to express this in this other library, right? And I think that the consequence of this is that we end up using the relational databases in kind of only the simplest ways. We almost use, most applications I've seen use the relational database almost like a key value store, right? Well, we have a key, we pull out a row, and that represents a record or in another language to be an object. But if we wanted to express more complicated queries, maybe things that involve windowing functions or recursive common table expressions. I don't know if anyone knows what that is. Does anyone know what those are? Yeah, okay. How would you represent that in some sort of templating engine or an Ecto-like mechanism and have it not be just this kind of being so complicated that you're kind of learning this thing, learning the mapping to the SQL. It just doesn't seem like the right approach to me. But again, adds to the complexity. Now, so we say we successfully construct our query, and now we're trying to process the rows that get back. And there is a obvious sort of mapping where you can say, well, a row in the database could represent a tuple or a record, right? That seems like an obvious mapping. But then maybe it's not too obvious. So what about, we could use a map, right, where each of the keys are the column names, so that's not just positional, right, which would be the record. So that would give you a little bit more flexibility in how you construct the query, because you could reorder the columns without breaking your code, your Erlang code. But do we also need the type information, right? Do we need to know what the exact data types were? And so do we collect that information with the data? Do we make a separate tuple or a record or map that has all the type information for the columns? So there's even there some choices that are going to depend on what you're trying to accomplish. And this approach doesn't work well, in my opinion, for things that are nested. Now this is an example I took out of the GraphQL documentation. I actually only recently discovered GraphQL because we were using it in the project that we're working on. I'd never heard of this before, so it's kind of interesting to me. But this is an example of a list resolver in GraphQL. And the idea is a human is connected somehow to a list of starships, right? And so in this example, so we have the human, and in this example, we'll say, okay, so we'll retrieve we have the starship IDs, and then we're going to dip into the database for each one of those starship IDs to get the whole starship information. So if there were 10 humans and each human had 10 starships, we're going to probably do 100 queries, right? Or no, that's probably not right. Yeah, 100 queries, that's right. And so sort of the obvious way of doing this is to think of it as a many-into-many relationship, so we have a join table. And so we end up with sort of this order n operations against the database in order to flesh out this nested data structure. And this isn't great, right? Because if we think about how a database executes a query, there's a significant amount of overhead for every SQL statement that we send to the database, right? Because it has to parse, compile, and optimize that query, and only then does it actually execute the query. And so if we're going to do this 100 times, right? Say you have a system that can manage, I don't know, 10,000 requests a second. Well, now if you're going to do 100 requests to the database for every one of the web requests, now you're down to only being able to do 100 web requests a second, right? So that's not so good, right? So we could optimize this by doing it in one round trip, by kind of mashing the queries together. The tricky bit here is this left outer join to make sure that we get the humans that don't have any starships. But then we're saving time on the database, but now we're spending time writing complicated code in order to kind of construct that nested data structure. And really, this isn't terribly practical if there's more than one nested field or if the nesting goes more than one level, right? You can imagine this starts to get a little bit out of hand. So again, add some complexity because we kind of want to use the database in a more optimal way. And there's a bunch of other things we could talk about that didn't have time. Things like, well, what about multi-statement requests, right? In a relational database, most relational databases allow you to batch a whole bunch of statements together in one go, and then it sends all the results back. And there's some advantage to that because the database itself can sort of pipeline the processing of all of this. And that might be a way of solving this problem of multi-nested structures. You have to think about that a little bit. And also the question of how do you deal with parameterized queries, right? Where do you stuff the parameters? It also turned out we were working with Amazon Redshift, is that the right name? And it turns out that if you have a multi-statement, you can't parameterize it, which is just strange. It was this weird limitation. So again, adds a certain amount of complexity to how we decide to interact with the database. So what are the next steps, right? So like I said, my goal in this was to see if I can find other people in the community who have an interest in sort of trying to solve some of these problems to make it easier to integrate Erlang with a relational database. And so I think defining, I don't have a clear sense of sort of where the edges of this problem are, or even the boundaries within it. I was like, what are the sort of the boundaries of the different parts? I kind of laid out some thoughts on that, right? What is connection management and how to construct the SQL and how to process the results, but there might be other ways of thinking about it. So it might be useful to try to collect some other use cases. And then if there is enough interest, maybe we could form an informal or even formal working group to try to do some implementation. And that's all. Thank you.
Well, I personally am on the train to get people on SQL onto NoSQL. So absolutely, Marc, if there's anyone who can join in on this, please speak up to Marc. And
now I can see you.
Yeah. Any questions for Marc before we call it a wrap for this talk? Oh, sorry.
So first, great talk. It's really fun hearing another engineer walk through all of the ways things are horrible and awful. One question I have is, have you looked at kind of, I guess, other parts of the problem space around like cursors or around, I don't know, I'm mostly with the elephant these days, but notify, listen, that sort of thing?
No, but those are great topics, and I should have put them on there are other things slides. Yeah, cursors is an interesting thing. I think the other interesting thing to think about is how you do the paging of results. Like in a website, right, you usually don't return all 1,000 users or 1,000 things all at once. You page it back. So how do you represent that? How do you model that in the Erlang code with relation to the database? Where I am now, what they did was they use a windowing function to number all the rows and then say, okay, I want the third page, so I want rows 30 through 40, right? And you just do a where clause, right, to get those rows. Not perfect because it's computationally expensive on the database, but it would be one way to do it. Yeah. I think I lost. Oh, there it goes.
It was a great talk. So there's a lot of stuff that you captured and some things you didn't get to. So I can't wait for the sequel.
Okay, thank you. Well, maybe I've got my submission for Berlin.
Marc, is there a sense of prioritization among these things, that some things are more burning than others? Everything is burning, but
I think that's something I'd like to learn. I don't know. I think, to me, the more tractable problem is probably on the connection side. I think, following the model of what ODBC did, maybe the thing to do is to come up with a standard Erlang API to databases, and then that would give an opportunity to say, okay, maybe we want to, instead of using ODBC, directly use the TDS library from Microsoft or the Oracle, whatever they call it, library, right? And then just build the compatibility layer on top. But I only think that because to me that feels like the most tractable of the problems. But I think that things like result processing and query construction are probably the more interesting problems.
Marc, any idea about secondary indexing and where and when, depending on the complexity of the database you're attempting to ETL?
Oh yeah, I mean, this is more of a question about optimization of the queries, right?
Yeah.
Yeah. It depends on how the data is being used. You want to obviously, you want to avoid over-indexing the table because every update, every insert, update, delete, right, has to update the indexes. On the other hand, you have to look at the queries and in particular where the joins are to decide. There are some things that do happen. So, for example. If one of the tables is very, very large, it could be that the database will always decide to scan that table, and in which case, you maybe don't need to do a lot of indexing on it. The other thing that indexing could help with, depending on how good the optimizer is on the order bys, right? So if it can discover that there is a useful index because of the order by, I know a lot of databases may do optimizations around this with timestamps, right? Because a lot of data is timestamp driven. Maybe there's a sense to put the index there. I actually, when I was at Sybase, this is like almost 30 years ago, I did co-author a book on the performance of Sybase, and we did talk about a lot of these topics, at least in relation to Sybase, which is probably now all completely out of date, because it was 30 years ago, right? Things change.
Such is structured data. Okay, without further ado, let's call it a wrap. Thank you, Marc. Yeah.
Thank you.